All right, in this video, we're going to go over two kind of larger examples that have to do with that coordinate geometry that we just learned about using our coordinate proofs. So in this case, given the triangle below, you can see that it's put onto the coordinate grid. We have our y-axis here and our x-axis here. And it tells us the actual coordinates of our point here, of our corners that make up the triangle, x, y, and z. They're all right there. Okay, so it says, given the triangle below, graph the mid-segment MN, which would be parallel to XZ. Verify that this segment meets the criteria of a mid-segment. So remember, by definition, a mid-segment has to be parallel to the other side, and it has to be half of its length. Okay, so if XZ would be this line, is the one that it needs to be parallel to, then MN has to be in between the other ones. So M is going to be somewhere on this line over here. We're not quite sure where. And N is going to be somewhere over here. And again, I wrote down M is the midpoint of XY. N is the midpoint of ZY. Okay? To find out what that is, I don't know if I'm going to have a whole lot of space to do it on this page, so you can follow along still. You should have enough space on yours to do it some point, but I'm going to go over here and we're going to find out what it is. So remember, M was a midpoint, and we said that it would be between X and Y. So if we're using X here and Y here, again, using our midpoint formula, the X value of it is going to be X2 minus X1 over 2. So Y, or 5 plus 1 over 2. Again, our new Y value is going to be Y2, this 5, over Y1, this 1, or not over, Y2 5 plus Y1, which is 1, all over 2. It's our average of the Y values. In both cases, 5 plus 1 over 2, 5 plus 1 is 6, divided by 2 is 3, so M is going to be at the spot 3, 3. So we can go back to this one over here. We would say M is going to be at 3, 3. And now we can draw it in. We'll go over 1, 2, 3, end up 1, 2, 3. And we'd say M is this point right here. And I'm actually going to erase that piece, write in M. That's our midpoint. Okay? Let's go back to our other screen and find out where exactly N is going to be. Remember, that's going to be between Z and Y right here. So I would use X2, this 3, plus X1 from our value Y over here, 3 plus 5 over 2. That's going to be our new X value. Again, if we want our new Y value, I use Y2, it's the 9 from Z, plus the 5 here, our Y1, 9 plus 5 over 2. So I used our two Y values. 9 plus 5 is 14 over 2 is 7. 3 plus 5 is 8 over 2 gives us 4. 4 and 7. That's going to be our midpoint, or the coordinates of N. So let's go back. CY, so N is going to be at 4, 7. Okay, come over 4, puts me here. 1, 2, 3, 4, 5, 6, 7. Right here is going to be N. Okay, now that I have my two actual midpoints, M and N, I can just connect them. I got a little bit off on the smartboard, but I connect those, and that supposedly it should be our mid-segment. We took the two midpoints and we just connected them. Okay, but because it's a mid-segment, we have to prove that it is exactly half the length there, and that it is parallel. Or should I say, because we use the midpoints, we're going to use that to prove that those lines are parallel and that one of them is half the other one. So to prove that they're parallel, let's find the slope. So if we're going from X, this one here, to Z, what is our slope there? Remember, slope is our change in Y values. That's our Y2 minus Y1. So we would use 9 minus 1, and we would get 8. So 8 is our value on top. we would use 3 minus 1, we would get 2. So we have 8 over 2. And again, another way to check that is if we start here and we go 1, 2, 3, 4, 5, 6, 7, 8. We're moving 8 spaces up. I'm going to get rid of some of this extra drawing we don't need. So that's how we figured out that slope is 8 over 2. And we can reduce that. 8 over 2 is actually 4. So the slope of xz is 4. Okay, let's do the same thing with the slope of m to n. So n was at 4, 7. We're going down to 3, 3. So this 7 minus 3 is 4 over 4 minus 3 is 1. And again, we can reduce that. 4 over 1 is 4. So in that case, we can see they have the same exact slope. And if they have the same slope, they have to be parallel. So at this point, we've proven that they are in fact parallel. We know that for sure. But we still have to prove that mn is half the length of xz. To do that, we're going to use our distance formula. So we know x and z, we know m and n, so we just plug them into our distance formula. So the distance of x to z is going to be the square root of everything, the quantity 3 minus 1 squared plus the quantity 9 minus 1 squared. 3 minus 1 is 2, so we'd have 2 squared, plus 9 minus 1 is 8, so 8 squared. 2 squared is 4, 8 squared is 64. So we have the square root of everything underneath it, 4 plus 64. So that becomes the square root of 68, which is approximately 8.246. And another thing that we can add on here, the square root of 68. You can break your square roots up into square roots multiplied by each other. Square root of 68 actually equals square root of 4 times the square root of 17. And we know that because 4 times 17 is 64. Well, I can say then square root of 4 is for sure 2. So it's actually 2 square roots of 17. 2 times whatever the square root of 17 is. That's what the distance from x to z is going to be. Okay, let's find the distance of mn. Okay, again, plugging everything into our distance formula, we would have 4 minus 3 squared plus 7 minus 3 squared. And all of that underneath the square root. 4 minus 3 is 1, so we have 1 squared. 7 minus 3 is 4, so we have 4 squared, all under the square root. 1 squared is 1, 4 squared is 16. So it's 1 plus 16 all under the square root. 1 plus 16 is 17, so we have the square root of 17, which is about 4.123. Now notice, 4.123 would be half of 8.246. They're exactly half. And if you didn't believe me, if you said, well, you know, if you look at all the decimals, I mean, we rounded, so you can't say they're exactly half. Well, in this case, this is 1 square root of 17. This one is 2 square roots of 17. So this one is, in fact, double what this one is. Okay? If it's double, so the distance from x to z is 2 square roots of 17, and this is only 1 square root of 17. And again, if you want to plug in the decimal forms of this, that's okay. But because we figured out one of them is 2 square roots of 17 and one is only 1 square root of 17, the same slopes, again, 4 and 4, mean they're parallel. We've proved that they're parallel. The distance mn is half the distance of xz, so it's half the length. This is half of this. So we proved that all mid-segments, anything that we use, or again, in this kind of case, we figured out that they're going to be parallel. Found out the slopes have to be. And we found out that the distance, or the length, of the mid-segment is going to be half the length of the other side. Our last example, again, it's going to be kind of a long one using this coordinate geometry. We're going to plot out the points first, plot out our triangle ABC, and then using that we're going to find a midpoint M. It's between A and B. We're going to verify that C to M is perpendicular to AB. So we're going to have to use slopes to do that. And then we're going to verify that the length AC equals BC. So we're going to have to use the distance formula on that one. So on this one, it's not necessarily drawn in. Make this side be the y-axis, and make this side be the x-axis, so that this would be 0, 0 right here. We don't have any negative numbers, so it's nice and easy to plot out our points. If we say that A is at 2, 6, we go over 2 and up 1, 2, 3, 4, 5, 6. So right here is our spot A. Same thing with B. We're going to go over 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 2, 1, 2. So right here is our spot B, and C would be over 11. So if this was 8, 9, 10, 11 right here, up 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is right here. So it looks like we had some space to use if we needed it, but we don't really need to go much bigger than that. Here we have A to B, B to C, C to A. That's the triangle that we're going to be working with, triangle ABC. Now first off, we need to find the midpoint of AB. So it's going to be somewhere in here. That's our point M. Okay, so I have to plug that into our midpoint formula. So I'm giving myself some space on a different page. If A is 2, 6, B is 8, 2, and C is 11, 13, M is the midpoint of A and B. The X value is just the average of the X's. So 8 and 2, add them together, divide by 2. The Y value is just the average of the Y's, 2 and 6, and then divided by 2. 8 plus 2 is 10, divided by 2 would be 5. 2 plus 6 is 8, divided by 2 is 4. So M is at the spot 5, 4. So we can go back, plot that on here. 1, 2, 3, 4, 5, right here, up 1, 2, 3, 4, right there. That's where M is at. Oh, I suppose I can write that here too. 5, 4. Okay. Now, if I were to connect this CM, I have this spot here. I need to find the slope of CM and the slope of AB. Well, going from C to M, or let's use from M to C, I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going over 1, 2, 3, 4, 5, 6. So I can say it's 9 over 6. Okay? Or if you wanted to plug in the actual points, use these ones and these ones. Again, 13 minus 4 would be 9. That's where the top number comes from. 11 minus 5 is 6. That's where the bottom one comes from. And we can simplify that. 9 over 6, divide 3 out of both of them, and we get 3 over 2. So our slope is 3 over 2. Now let's look at A, or should I say AB. Let me move some of these out of our way now. Going from A to B, same thing. We're going down 1, 2, 3, 4, and then we're going over 1, 2, 3, 4, 5, 6. So we would say down 4, or negative 4, over 6. And again, if you wanted to use the points A and B, oops, I didn't mean to cross through them, A and B, we'd say going from A over to B, we would use 2 minus 6 is negative 4. 8 minus 2 is 6. That's where we got our negative 4 over 6 from. And that one, again, we can reduce, take 2 out of both of them, negative 2 over 3. Notice how positive 3 over 2, negative 2 over 3. Okay? Again, we call that opposite reciprocal. So we have opposite reciprocal slopes, which means they are perpendicular to each other. So although it may not look like it, we actually know for sure because the opposite reciprocal slopes that these are going to be perpendicular to one another. And get this circle out of there. These intersect each other at a 90-degree angle. Okay, now I need to make sure that AC equals BC. Because now that we showed this is parallel and that M is a midpoint, if M is a midpoint, this equals this. So it looks like M to C is actually what's called the perpendicular bisector. Okay, because it's a perpendicular bisector and C is on that perpendicular bisector. Remember, our perpendicular bisector theorem said that this length should be just as big as this one. So we need to prove that that's true using our coordinate geometry. So we need the distance A to C and the distance B to C. We'll come back over here and, again, plugging everything into our distance formula. A to C, plug in our x values, 11 and 2. 11 minus 2, we'll square that. Plug in our y values, 13 and 6. So 13 minus 6, and then square that, and we'll take the absolute value of everything. So it becomes the absolute value of 11 minus 2 is 9 right here. 13 minus 6 is 7 right here. So it's the square root of 9 squared plus 7 squared. Becomes the square root of 81 plus 49. Becomes the square root of 130, which is about 11.402. All right, let's look at B to C. Same thing, we just plug it into our distance formula. We'll use, again, 11 as our x value and 8 as this x value. So 11 minus 8 goes into the first spot. Get rid of some of that. Our y value then, 13 minus 2 is the second piece. Simplifying that one, it becomes 11 minus 8 is 3. So the first part became 3 squared. 13 minus 2 is 11. So the second part became 11 squared. Well, 3 squared is 9, and 11 squared is 121. So now it's all the square root of 9 plus 20, or 121. 9 plus 121 is 130. So we have from B to C, the distance is the square root of 130, which is about 11.402. Again, in both cases, they are the same. So we can come back here and say the distance from A to C is square root of 130. And from B to C is also 130. Smartboard's getting a little off. So what does that tell us? Same distance between the two means AC equals BC. So we know that this piece right here is our perpendicular bisector because it's a midpoint right here, and this piece is perpendicular. C happens to be a point on that perpendicular bisector, so this length has to equal this length. We've proved the perpendicular bisector.